Hello, Matthews, Gatos here. In this video, I'm going to prove the product rule. Now, the product rule is a way to find the derivative of two products. So what I'm going to do is I'm going to have some function f of x represent the product of two functions. So let f of x equal f of x times g of x. Then I'm going to take the derivative of that product using tangent definition number 2. So let's look at what this will look like. So the limit as h approaches 0 of f of x plus h minus f of x all over h. So because f of x is the product, it's going to be f of x plus h multiplied g of x plus h, and then minus f of x, which is just the product of the functions, all over h. Now I can't substitute h in right now because I would have division by 0. So what I'm going to do is I'm going to change this form a little bit. So I'm going to keep my first and my last part, but in the middle, I'm going to add and subtract something just to help me with some factoring. Now I can add and subtract anything to a function because adding and subtracting the same thing is like adding 0. So what I'm going to do is subtract f of x plus h times g of x, and I'm also going to add f of x plus h times g of x. So I haven't changed the question because adding and subtracting again is like adding 0. So what I'm going to do is I'm just going to group these into two different pieces. So I have the limit as h approaches 0 of, and now I'm going to do f of x plus h. I'm going to factor that from my first two terms. So that's f of x plus h times g of x plus h minus g of x. So I've just looked at my first two terms and factored that out. Then I'm also going to, in my next one, factor out a common factor of g of x. So in the next one, I'm going to say plus the limit as h approaches 0, factor out a g of x. So this would be g of x times f of x plus h minus f of x. And again, this is all over h, as is this. Okay, now that we've done that with factoring, I'm going to separate this just a little bit further like this. The limit as h approaches 0, I'm just using all of my product or my rules of limits multiplied by the limit as h approaches 0 of g of x plus h minus g of x all over h, and then plus the limit as h approaches 0 of g of x multiplied by the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, let's look at what we have right now. If I look at where I started with the definition of tangent number 2, and this is how I find the derivative of f of x. So f prime of x is this limit. So if I look at this piece right here, following the template here, limit as h approaches 0 of g of x plus h minus g of x over h, this would just be the derivative of g of x. This part right here is tangent definition number 2, and I know that that's f prime of x. So I know that that is the definition of a derivative. Now look at what I have over here. The limit as h approaches 0 of f of x plus h. I can safely plug in h being 0 there, which would just be f of x plus 0. And then plus here, I can also substitute in h equal to 0. There is no h value. So that would be like the limit of a constant, which is just a constant itself. So what I have right now is the derivative of f prime x. Let's tidy this up a little bit. F prime of x is equal to f of x g prime x plus g of x times f prime x. And if I just write this here so that they're all in the same order, this is just f of x g prime x plus f prime x g prime x. And this is the product law. So this is a way of us finding the derivative of a product, formally stated like this. The product rule. If f of x and g of x are both differentiable functions, then the derivative of the product is equal to f prime g plus fg prime. Basically, what that means is that the derivative of a product of two functions is the derivative of the first function multiplied by the second function plus the first function times the derivative of the second function. So now I've proved the product law and I can use it for any type of a product. So I hope that this video helped. If it did, please give it a thumbs up and hit subscribe so I can help more mathies just like you. Thanks for watching and see you for the next one.